This video will cover how to do a realistic sprinting system. It features the player being able to run faster if a button is held. The FOV will be increased smoothly to give a greater sense of speed. Footsteps during sprinting will also cause camera shake and leave a dust particle behind for realism. This system will also show how to make a running stop system, so when the player stops sprinting, a stopping animation will play. First, I will download the animation from Mixamo. It is called Run to Stop. Make sure to download it without skin, as we just need the rig animated. I will use this Mixamo converter software so I can convert the skeleton to the Unreal Engine 1. I will put a link to this in the description. Next, I will make a new folder for sprinting. Import the animation. Create a montage of it. This is so we can play it in the blueprint and blend in and out of the regular states. Open the animation and enable root motion for it. Open your player blueprint. I will now make a new input axis event for sprinting. You can duplicate the jumping input from the third-person template and rename it. Open the input mapping context and add a new mapping. Set this to the sprinting one. For the input, I will use left shift. Since I used left shift for the sliding system from a previous video, I will replace it with left alt so there is no overlap in input keys. Add the sprinting input event. Create a new Boolean variable called isSprinting. Set isSprinting to true on started. Next, we will set the max walk speed. Promote the value to a variable called sprint speed. I will set the default value to 700, but you can change this to be faster or slower. Next, drag out of completed and set isSprinting to false. Set the walk speed again, but this will be setting it to the default walk speed. I will again promote this to a variable. Open the animation blueprint of your character. Find the default walk run blend space. Make a copy of it for the sprinting one. Change the maximum axis value to the sprint speed you set. For the sprinting animation, I will use the male run forward animation from the default mannequin animation. Since it's not that fast, I will change the rate scale to 1.4 to speed it up. Add the sprinting animation to the end of the sprinting blend space. You can hold Shift while dragging to snap to the grid. Promote the player blueprint cast output to a variable. Get the sprinting variable from it and promote it to a variable. Open locomotion in the animation graph. Add the sprint blend space to it. Create a connection from walk run to sprint and back. The condition to go to sprinting will be is sprinting. The condition to go back to walk run will be checking if sprinting or should move is false. Make sure to set the speed variable of the blend space to ground speed. As you can see, the player now sprints. Go back to the player blueprint. Next we will check if the player has stopped running but the left shift key is still held down. Get the speed of the player by getting the vector length xy of the velocity. Next get the current acceleration and check if it is not equal to 0. Check if the speed is greater than a small speed value such as 10. Add an operator with these two as the conditions. Add a branch node and set the condition to the n operator. Next, add a sequence node. Add a do once node. Connect then 0 to reset. Connect false to the do once. On completed, connect it to the code that stops sprinting. Connect then one of the sequence to the sprinting code. Next get the triggered seconds and get greater than from it. Set the value to 0.75. This means the stop animation will only be playing if the player has been sprinting for almost a second. Add a branch node if this is true and check if the player is falling, as it should not play in air. Replace the connection from setting is sprinting to false to just setting the walk speed. Set is sprinting to false in this false path. Next we will check if the player is sprinting before the stopping animation actually plays. This is just an extra check so there will be no bugs. The final branch will check if the player is going above a certain speed before the stopping animation plays, as enough momentum has to be reached before the stopping animation is necessary to play. I will check if the speed is above 50. If true, then set is sprinting to false. Then play a montage from the mesh. Set the montage to the run to stop montage. Go back here and make sure you get the last update velocity and not the requested. The player now plays the run to stop animation if they stop sprinting after moving. I will now comment the code we just scripted. Open the sprinting animation and add a new notify track. Create a new notify called Footstep_L. Add this every time the player's left foot hits the ground. The default animation already has markers for this, so I will just add it using those. Do the same for the right foot with another notify called Footstep_R. Add the two notifies in the animation blueprint. I will use this free asset for the footstep particles. Import it to your project. We will now do a trace to check if the footstep particle should be added. Get the socket location from the character mesh. Do a line trace from here to an offset of something short like 10 on the z-axis. Drag out of the return value and add a branch to check if anything was hit. If true, then spawn a system at location. Set the location to the socket location. Convert this code into a function. Set the socket name to an input. Add a return node after false and after the spawn system. I will use this General 1 Niagara system. Set it as the system to spawn. Next go back and set the input to foot_L. Duplicate it for the right footstep and replace the socket to foot_R. The socket names may be different if you are using a different skeleton with a custom bone namespace. It is a bit difficult to see the particle, so I will increase the opacity of the color for the particle. Add the footstep_L notify to the run to stop montage as well. Next we will add camera shake as well for the footsteps. Create a new legacy camera shake component. Copy the same values. This will produce a soft but visible camera shake. Go back to the animation blueprint. Get the player camera manager and start camera shake. Connect this after both footstep traces. Set the class to the sprint camera shake we just made. You can change the scale if you want to make the shake stronger or weaker. I will now add some footstep sounds. You can add this to play during regular walking as well, but I will demonstrate it for sprinting. I will import these 4 sound effects I downloaded for free. Create a sound cue. Add all the sound effects and connect it to a random node so that each footstep sound effect will be randomized. Connect it to the output. You can change the volume multiplier if it is too quiet. Play this sound effect at the player's location. It works, but the sound effects are not that good, so I will change them off camera to better quality ones. Finally, I will make the field of view increase when sprinting. Add a new timeline, as we will use this to interpolate the FOV value. Set the length to 1 and add a float track. Make it go from 0,0 to 1,1. Select both points, right-click, and set it to user so it is not linear but curves in and out. Connect it after setting the sprint speed. Add a sequence node. Connect it after setting the walk speed. Connect then 0 to the reverse of the timeline. Connect then 1 to the rest of the stop sprinting code. Get the follow camera and set the field of view. Drag out of the input and get a lerp node. A should be the default FOV, which is 90. Set the B value, which is the target, to something slightly higher like 110. I will reduce it to 100. I will also make the timeline shorter by setting the length and final point time to 0.5. It is looking better now. Add a branch node before playing the timeline. Copy this code that checks the speed and replace the last update velocity with velocity. Set the value to something high. I will change it to 500. The FOV is now changing when the player goes fast enough while sprinting rather than immediately when they start moving while sprint is held down. That is all for this video. If you enjoyed, like and subscribe for more content. Thanks for watching.